Right now, let's get effectively a case study, really, some working code. Oliver Joseph Ash is a developer at The Guardian, and you might have seen that The Guardian have a very adorable offline page for those situations when you just can't predict when the network's going to fail. And he's going to talk through it now. So I'm really looking forward to this because I'm a big fan of service workers. So this is right up my alley. Big welcome, please, for Ollie.
Okay, can everyone hear me? Just to check. Thank you. So today I'm going to be talking about building an offline page for theguardian.com. But before I get started, so I'm a software engineer at The Guardian. I used to work on Composer, which is The Guardian's digital content management system. Also a web app. But now I work on theguardian.com, where I'm working full stack to just do A/B testing, feature development, this sort of thing. I'm going to start by comparing web and native and how these different platforms perform when you have bad network. A native app, when you open the native app, the content is cached. So the next time you visit and you're offline, you'll get the stale content, just like the Guardian app you see here. You can actually go into the articles, you can read them, even though you're offline. If the server's down, the same happens. You'll see the stale content. If you have a poor connection, the same happens. You'll see the stale content until the new content arrives. And finally, if you have a good connection, the same stale while revalidate, you will get the new content much faster because you have a good connection. We all know this because we all use native apps every day. But on the web, well, it's not so good. If you open up theguardian.com and you're offline, this is what you get. You get an offline page that has a game to kind of settle the blow a little bit. But if you tap the dinosaur, you get this little game. I'm not very good at it, as you can see. Server down. If that request fails because the server has gone down, the same happens. You get nothing. And if you have a poor connection, you'll just be staring at a white screen until the content loads. If you have a good connection, finally, we get what we want. You get the content. But you can see that the web is really inferior to native when it comes to bad network. But we can do better. So at The Guardian, we experimented with one of these criteria, which is when you're offline, what could we serve instead? And we built this offline page. So I'm on The Guardian. I'll go offline. And when I refresh, because I'm offline, then I get this page with a crossword that I can play while I'm offline. We already have crosswords on the website, so this was kind of just a fun idea that we could bring in some code we already have onto the offline page. Quick note, the offline page, if you want to test it, is available at theguardian.com/info/developer-blog. This is because, as we'll see, service workers, which is how the offline page functions, is only available on HTTPS, and theguardian.com is still migrating. Okay, so how does it work? I'm going to talk about this in 4 parts. The first part is creating and registering what's called a service worker. There's been loads of talks recently about service worker, but I'm briefly going to describe what a service worker is again for those who haven't heard. It's a script that runs in the background, and it's useful for features that require no user interaction. So this might be something like listening to a push event and sending a notification. Or it might be intercepting and handling network requests, which is what we'll use for the offline page, as you'll see. But in the future, it will be expanded to do other things like background sync if you want to update some data on a schedule every morning, for example. Or if you want to perform an action when the user enters a geographical location, like when they get home. And it's a progressive enhancement because without the service worker, the web just works as it was before. It's HTTPS only, and it only works in Chrome and Firefox today, although Safari are expressing some interest, so Edge, but how long before we actually get it in those browsers, who knows? So quick note about HTTPS. theguardian.com isn't HTTPS, but we're moving some of our sections over. So we've currently got /science, /crosswords, and /info on HTTPS. And we've also got an internal opt-in, so people in the building can opt in and have a play. That's a really good way to test it. And we've actually already found a few problems with it so far. Okay, so the first thing, as I said, is creating and registering what's called a service worker. Let's imagine we create an empty file, just call it service worker.js. And in the HTML for our website, we're going to add a simple script which says if service worker is supported, then we want to register a service worker, which is the empty file we just created. So as you can see, this is a progressive enhancement. If service workers don't work, well, it just won't register it. Any subsequent visits to this website, theguardian.com, will be routed through the service worker we just registered. So now we have a service worker. Any request will go straight to the server and back. It won't go through the service worker because we're not currently doing anything with our service worker. You can see you have a service worker installed. If you're interested, open up Chrome DevTools and go to Resources and then to Service Workers. One really handy tip is you can actually inspect the service worker as if it was its own window. If you click Inspect. Likewise, in Firefox, if you go to About Debugging, you can also debug the service worker there. Okay, the next thing we're going to do is we're going to get ready with the install event. The install event is something inside of the service worker that is called, of course, when the service worker is registered. So it's a great time for you to prepare. In our case, we want the offline page to use some cached assets. We're going to cache some HTML, some JavaScript, and some CSS. So in the install event, we say update the cache. That function uses the new cache API that came with the service worker API to prime the cache. So you can see cache.add all offline page and some CSS and some JavaScript. So now these are in the cache, we can use them later. So we have a service worker and we have a cache, but they're not currently being used. All network requests are just going straight to the server and back. So how do we actually do something? So the way to do this is with what's called the fetch event, which allows us to intercept any request that goes to the server. You can see at the bottom of this code, I'm just extending the code we had before. The default behavior would be just to make a request to the server and back. Here, I'm overriding the default behavior, but I'm doing exactly the same as what the browser would do anyway, which is just to make a request. That uses a new fetch API, which just makes a network request. But you could also use this to read from the cache instead. You don't have to go to the network. If you know that you have that thing cached, well, just don't go to the network at all. And you can also use it to construct your own responses. Okay, so now we actually have a service worker that's being used, and all requests are going through the service worker. Just a quick note to give you some idea of the flexibility you have with service workers. As I said before, you can construct your own responses. So here I have a string of HTML. It just says hello world in the H1. And I can use the response constructor and respond with that. It's just a string of HTML, but I can actually respond with that. This is useful for, it might be useful for something like templating in a service worker where you actually make a request to the network to get some JSON, and then you want to compile that into HTML and respond to the browser with that. Okay, so how are we going to use the fetch event to deliver the offline page? I'm going to break this down into two parts. I'm going to talk about how we handle HTML requests and how we handle other requests for assets. This is the code we have already. I've just guarded the response to say only do this if the request is a HTML request. The way we do that is we look at the accept headers of the request. That will tell us if it's a HTML request or not. So this code actually hasn't changed, but we will elaborate. What we would like to do is we would like to, for HTML, we want to go to the server first because HTML is dynamic content. We can't just go straight to the cache. We always need to check if there's a new version. But if there isn't, we want to go to the cache instead. This is commonly known as network first and then cache. In our case, we want to fall back to the offline page. So if we can't make the network request, there's an error, then we'll serve the offline page instead from the cache. Here we have the code you've already seen. It's just in the fetch event, we're saying if it's a HTML request, then just do a normal fetch. But fetch actually returns a promise. So if you're not connected to the internet, then this will error, and we can catch that error and retrieve the offline page from the cache. And there we have it. That's how you serve the HTML for the offline page if you're offline. It's really simple. As for assets, we need to handle those slightly different. With assets, because we version them in the URL, that means they're static. So if they're in the cache, we can just serve that. We don't need to go to the network first. How do we do that? Okay, so this is the code we had before. And we'll just say, otherwise, see if it's in the cache. So this is currently what we have, but there's a problem here. The problem is, if that item is not in the cache, it will just fail. So what we would really like is we would like to go to the cache first, and then if that fails, we want to go to the network. How do we do that? Well, caches.match returns a promise. So we can just say .then, look at the item we've pulled out of the cache. If there is a response, then we'll return that. Otherwise, we'll go to the network instead. Okay, the next part to the offline page is updating the crossword. The Guardian publishes a crossword every day, and ideally the crossword will show the latest crossword. We actually have HTTPS on the crossword section now, so this would be really handy to those crossword users. They would really like to have the latest crossword if they are offline. But also, if we make any style changes, we need a way of updating those as well. So the way to do this, I've faded some of the code here because it doesn't really matter, but the general principle is in the service worker, we can just say, is the cache updated? If it's not, then we can update the cache and delete the old caches. The way we know if the cache is up to date or not is by we can name the cache using dates. And this code is in the global scope of the service worker. So every time the service worker boots up, it will run. And that actually happens quite frequently because browsers will close the service worker in order to save memory. So every time you come back to the website, this code will run again. Although it's not entirely ideal, there should be a better way of doing this. And there will be in the future. There will be something called the background sync API that will allow you to say, I want to update some given data every hour or every day, but that's not available yet. Okay, so we have an offline page, and that's all the code you need to get an offline page working. It's actually really simple. So in the future, we might use service workers for other things, but firstly, offline page will increase in significance. Right now, HTTPS is only on a few sections of the website, and we've had to actually limit the offline page to a very specific section because of browser bugs. But as those problems go away, more people will see the offline page. So we would like to extend it. We would like to do what you saw with native apps at the beginning. Maybe we could show stale content, the content that you had the last time you opened the website and you were online. We could show personalized content downloaded ahead of time, so we know what kind of articles you like. We're going to download 10 articles similar to the things you've read recently, and show that to you instead. Or we could use the Save for Later feature that we have on the website today and just download those. Or we could go fully offline first. What do I mean by offline first? Well, I mean you would instantly respond to navigations with a shell of the page. And this improves the experience for users with a poor connection because they tap something and you get a response straight away, which means you don't have to just stare at a white screen while things are loading like you do on the web today. You can actually do this today already with client-side rendering, but the difference with service workers is that this also holds true for the first time you open the website. Whereas with client-side rendering, if you have a poor connection, you still have to download the shell. If you have service workers, the shell will be cached. So the first time you go to the website, it will load instantly. So just to give a demo of what that might look like, this is The Guardian today, and we have an article called Building an Offline Page for theguardian.com, very meta. And I'm gonna navigate to that. And nothing happens until the content has been downloaded. And you actually see users like tapping links like 5 or 6 times because they think nothing's happening. It is happening. They've just got a really bad connection. And what I'm talking about is something more like this. You tap on a link, and you get feedback straight away. You don't get any content, but at least you know something's happening. It's worth noting that this would be done as a progressive enhancement. So if you don't have service workers, you would still want to render on the server and deliver HTML. If service workers are supported, then you could do this sort of shell architecture, which is kind of what Forbes was talking about with server and client-side rendering. Okay, so what problems did we have? If you're going to go ahead and build an offline page, I hope you do, what sort of problems might you run into? Well, I ran into a few browser bugs in Chrome and Firefox. And because the service worker intercepts all requests for that domain, for that host, the bugs can actually be quite painful. So we had one bug which was dropping all cookies, which meant that comments weren't working on HTTPS sections, for instance. I was able to work around it, and I worked with the Firefox team to file that issue, and they're going to fix it if it's not already fixed. The other problem we had was with our CDN. So the CDN wasn't the problem itself, but just briefly to explain, let's imagine we have two assets. We have offline page HTML and we have service worker.js. And each of these assets have a different cache expiry time. The offline page will expire after 60 seconds, the service worker will expire after 120 seconds. So these assets will live in the CDN's cache until they expire, and then they'll be renewed. So currently we have version 1 of each asset. At some point in time, we deploy, which means that there's actually a new version of those assets available. But the CDN still has version 1 cached. Until it expires, it will still have version 1 cached. So the offline page, after 60 seconds, it expires, and we get the new version. But the CDN still has the old service worker cached because you have this interleaving of cached items. Eventually, you will get both versions of the asset in. You will get both versions at the same number. But if you end up with, if your browser ends up requesting the old service worker and the new offline page, those assets could refer to different asset versions. So then the whole thing just falls down. The way we serve this is using something like a manifest, which just describes this is the HTML that you need for the offline page, and these are the asset URIs you need. And this means that we only need to rely on the cache for one item in the CDN. In our service worker, we can fetch this offline page JSON, and the HTML will just be constructed as a custom response and stored in the cache. And we can then go ahead and request all of the assets. This guarantees that you have the same version of the HTML and the same version of the assets. So it's a bit of a tricky one. You might not run into that one if you don't work with a CDN. OK, so why did I do this? I admit I did it because it's fun. It's always fun to experiment with new browser technology. But also, as I said earlier, the page will grow in significance as browser support widens and as the migration to HTTPS progresses. And it's good to plant the seed. Now we actually have it there. People might say, oh, maybe we could do something with the offline page. Whereas previously, people don't realize that the web can work offline. And finally, it's good because it irons out browser bugs. I have actually helped Chrome and Firefox to solve to find browser bugs. I really like this quote by Nolan Lawson. If we only use features that work in IE8, then we're condemning ourselves to work in an IE8, to live in an IE8 world. The point is that you should try and use new technologies because otherwise they'll never be adopted. OK, so in conclusion, browsers, service workers allow us to progressively enhance the experience for users who are offline and also users with poor connections. And it's really easy to build an offline page. I really hope that's demonstrated to you from this talk. The code is just really, really simple. And if you want to start playing around with service workers, building a simple offline page is a really good place to start. If you want to do some further reading, here are some links. I wrote a blog post about how I did this, which is kind of similar to this talk. And there's a really good explainer on service workers by Alex Russell, who works on the service worker spec for Chrome. You can also take a look at the Guardian service worker. I'll confess that the code isn't as clean as what you've seen here because we've had to work around various browser bugs, as I've said. And these slides will be available later, so you can more easily copy these links. That's all I have. Thank you for having me.